force on Q3 due to the charges Q1 and Q2. There are three charges at the position of the vertex of a triangle. Q3 at the top, which is 65 microcoulomb, and Q2 at the bottom, which is 50 microcoulomb, and Q1, which is negative charge, negative 86 microcoulomb. The force between Q3 and Q2, or we can say the force on Q3 from Q2, it will be a repulsion force, obviously, because both of the charges are positive charges, so it's going to be an upward force. So how to get it? We need to apply the Coulomb's law. The formula for the force will be K times the product of the two charge Q2 times Q3 divided by the distance between them, square it. So the K constant is 9 multiplied 10 to the power of 9. The unit, let us keep it as it is, because the space is not enough this time to write the unit. So let's write it. F3 on 2 will be 9 times 10 to the power of 9 multiplied with Q2, it is 50 microcoulomb, means 50 times 10 to the power of negative 6, and Q3 the same way, 65 times 10 to the power of negative 6. This is whole over the distance between them is 30 centimeter, which will just to be changed into meter divided by 100, so it's going to be 0.3 square it according to the formula. So this result will give us 325 Newton. This force is an upward force. Okay, let us continue to the second part. The second part will be the force on 3 from Q1. That's going to be an attraction force, because here it's a negative force, a negative charge. Q1 is a negative charge and Q3 is a positive charge, so unlike charges attract each other, so it will be the same way slanted to the down direction. So the formula the same. The K is 9 times 10 to the power of 9 multiplied with 65 multiplied with 10 to the power of negative 6. Again Q1, which is negative 86 times 10 to the power of negative 6. The whole over the distance between them is 60 centimeter. When you divide by 100, it's going to be 0.6 meter. So we need to square it, 0.6 square. So finally this result will be 140 Newton approximately, or nearly. Okay, now what is next? Since we are asked the resultant force, or the total force, which will be exerted on Q3 from Q2 and Q1, we know that the force which will be applied from 2 on 3, it is 325 Newton, which is upward force, but the force on Q3 from Q1, it is not vertical or horizontal, so we have to decompose it. It is somehow slanted, so therefore we have to draw here a horizontal line, and there will be a vertical line, obviously. Let us remove this part and let us try to decompose this one. This is F31. So this F31, by the way, this angle and this angle will be the same because they are alternate interior angle, 30 degree. So this is going to be F31 to the x direction, F31 cosine of 30 degree, because it is horizontal component, and the vertical component will be F31 sine 30 degree, because the angle we got it already. So each of them we have already. We can calculate cos 30 and sine 30, and F31 we have already, which is 140 multiplied with cos theta, and here also 140 multiplied with sine theta, and then we can get the x and the y components of the force on 3 from 1. That force has to be decomposed. It will be broken down, and then it will give us this way. Then let us see. So that F1, F3 on from 1, the x direction will be and F3, one in the y direction. We have two forces. The force will be 120 Newton and 70 Newton. F3, 1, the y is its downward force, that's why it says down. Therefore Fx, just only one Fx we have. The x component is just only F31x, which is 120 Newton. That's the only horizontal component we have. Where it is, we can plot it in somehow different color. Let's do it. Here it is. This is the only horizontal component force that we have. But vertically we have two forces. One of the forces is the force on 3 from 2 1, which is, we got it already, 325, that's upward. And the second one is a downward force. We got it here at last, 70 Newton. So the y component force, what we have, the resultant force on the y direction will be 325 Newton minus 70 Newton. So this is going to be 225 Newton, which is upward. Therefore, since we are asked the resultant force, we need to apply Pythagoras theorem this time. So the force resultant will be the square root of fx square plus fy square, which is square root of 120 square plus 255 square. Each component force are already got it, 120 the horizontal component, and the vertical component is 225, not 255, 225 we will have. So this result will give us 280 Newton. This is the resultant force which will be exerted on Q3 due to Q2 and Q1. But if we are interested to find the direction, what to do? The direction will be calculated. The angle theta will be tan inverse of the y component of the force over the x component of the force, which is tan inverse of the y component. We got it 225. So 225 over 120. So this one is approximately or nearly, we can get 65 degree. So these are the way how to calculate the magnitude and direction of force on Q3 due to Q1 and Q2.